Welcome back. More 6 Caillou fun. This is called Take a 10-Minute Walk. You live in the city of Cartesia, where all roads are laid out in a perfect grid. You arrived 10 minutes too early to an appointment, so you decided to take the opportunity to go for a walk. The city provides its citizens with a walk generating app on their phones. Every time you press the button, it sends you an array of one-letter strings representing directions to walk. So you get north, south, west, or east. You always walk only a single block for each letter, and you know it takes you 1 minute to traverse one city block. So create a function that will return true if the walk app gives you the, if the app gives, you will take you exactly 10 minutes. Sorry, that wording's messed up there. You don't want to be early or late. And will, of course, return to your starting point, return false otherwise. So the idea is, in a nutshell, you're going to get this array of directions. Instead of characters like they're depicted here, they'll actually be strings we can see. And so you need to determine if that collection of strings results in you making a walk that gets you back to your starting point in exactly 10 minutes, with the idea that you can execute one of these, you can travel one of these directions in 1 minute. So I think that's a little more clear. Go ahead. You definitely got this one. You can do this. 6 Caillou, but not bad at all if you think about the problem clearly. So go ahead and pause the video, come back when you're ready, and I'll go into a quick solution. So to solve this, I've got two main ideas. We've got the time constraint, right? We have 10 minutes. So we have to get back in exactly 10 minutes. It says too that they don't want to be too early or too late. They're saying exactly 10 minutes. Well, if I can do each of these in 1 minute, it follows that walk should contain exactly 10 elements, right? So if walk is not length 10, all bets are off, right? So I'm going to say walk.length equals 10, right? So this covers that part of it, just the length portion of it, right? And so the other component of this is that you can think of the directional pairs, the opposites, right? So north and south, east and west, and think of them as canceling each other. And if you think of it that way, what you realize is that the number of northerly directional walks has to match the southerly ones to get you back in the same vertical component, if you will. Imagine you're plotting your walk on a chart, right? If you go up 3 north, whether you do all 3 of those first or scattered over the course of your walk, if you end up traveling north 3, at some point you have to come back down south by 3, right? And then you can imagine the same thing happens with east and west. If you had traveled 4 to the east, you better make sure you're coming back 4 toward the west overall. And it doesn't matter what order you do them in, as long as the net result is 0 movement. That's what gets you back to your starting location. So what I'm going to do then is I'm going to use the count method that we learned about with LINQ, using system LINQ. And if you don't recall, you can check the doc page. Remember I told you to just keep enumerable open. You can look at all of its methods over here. So count, yeah, if you don't pass anything, it just tells you how many elements are in the array, just like length does for the array. But you know, we use it with the lambda, where we define how it should count. You give it a condition on when to count. So what do we have here? There you go, count. Takes an argument. In this case, they wanted the vaccinated pets, so we'll do something like that too. Okay, so we're back to, we got to add walk count. You have, let's call it, I'm going to call my lambda parameter here dir, short for direction. And so I'll say dir equals n, and remember I'm using double quotes because these are strings. Dir equals n. Yeah, so count the number of times that has, and I want to say, and let's and this, because all these conditions are going to have to be true to make the overall statement true. the length has to be 10, and the count of norths must equal the counts of south, right? Isn't that what I explained? And I'm going to add another condition. The counts of east has to be equal to the number of counts of west. And so here's a quick link way of doing this. The length is 10, and then the norths equal the souths, east equals the west. So if I run this, good, green, attempt. Pretty easy, right? Not too scary. There's no sort of graphing algorithms you needed to use or anything. You didn't need to pull out Dijkstra's for this or anything. So yeah, hopefully you're able to break that down. Simple enough. Easy money. I'll collect the points and see what else you can pick up from other people. Otherwise, let's do some more challenges. As usual, thanks for watching, and don't hesitate to reach out if you have questions or comments.